Okay, we're going to do a quick video on the bias here because I've had a few questions about it here in the last couple of days, and rather than explain it again and again, it's easier to make a video, that way everybody can reference to it in the future. With your bias here, your bias voltage comes in through your power switch. When you push it in, it supplies your line voltage to your RF choke here. Your RF choke operates off of pin 9. When you key the radio, pin 9 connects with pin 10. Pin 10 then supplies voltage over here in this corner, giving your meter movement voltage, giving your lamp voltage, as well as supplying the bias voltage. Your bias operates off this other RF choke here, which goes into the sandbar, 104 cap, 1.8 ohm resistor if it's a 2879 box, 1.6 ohm resistor if it's a 2290 box. Your 10 ohmers also come into play. Give me a minute here, I'm going to show you what kind of ohms we should see. Simplest way to test it, multimeter, put it in the ohm setting. Lowest setting you got, put your clip right there on your base. We have 1.3, 1.4, which is perfect. You want to then go to your second one, check it as well. .3 again. You want to be somewhere around 1.3 to 1.5. You then want to check your base voltage. The easiest way to do that is to take yourself a little pick here. I was in this one, so I gotta bend this capacitor back up in place. Go from ground to this 470 ohm resistor here. Alright, we're set up here. Got power to the box now. Box is powered on. We're going to manually key the amplifier while looking at the voltage that's on the base of the transistor. .63. It's more than acceptable. Come back here. You're going to do the same exact thing. Key the amp, see what the voltage is. The voltage should be pretty close, if not exactly the same. Now, let's talk about the different readings we might see. If we're testing the resistance on the base of the transistor, which this would be your input for the base of the transistor here. If you're seeing a less than 1.3, you're shorted to ground. One of the resistors here is shorted to ground. They need to be pulled and checked. If you're seeing more than 1.6, you have an open resistor. Be a 10 ohm or the 1.8, 1.6. If you're seeing 5 ohms, you have either an open, depending what's here, you have an open 1.6 or an open 1.8. If you check your bias voltage and it is 0, you have a short in the bias voltage. If you check your bias voltage and it is higher than 0.6 volts, like I said, 0.63, 0.62, that's more than acceptable. But if you check it and you have 0.72, that means that you have a resistance problem. The likely problem is going to be either a resistor again or a leaky transistor. Another thing with this bias in these Texas Stars, if you have a burnt bias resistor, 99% of the time you have blown pills. It's almost a guarantee, because at that point in time you're putting 12 volts to the base of the transistor, which is going to burn the pills out. This is actually a customer's box here, which I'm finishing up. You can see put precision 1.8 ohms in it. It was just a hair out of tolerance. Now it's where it needs to be. I have a 667 sitting right here next to it. I don't know who did what inside the bias, but these were used in place of the 1.8 ohmers. Measure this, it comes back about 3.5 ohms. That box at the base read 1.8. The bias voltage was, where was it? Somewhere around 0.725, 0.728, somewhere around there. Way too high. Way too high. The bias in these is extremely simple. Like I said, you get your power off the power switch here. You have L1, which is your choke. Pin 9. When your box is receiving, pin 9 goes to 8. When you key it, pin 9 goes to 10. Then comes into this power switch here. Comes out of the power switch, goes all the way over to your meter light, your meter, and here is your bias to the bases of the transistor. Very simple circuit, like I said. You have R21, which is a 25 ohm resistor, R16, which is going to be a 1.8 or a 1.6, depending which box you have. You have your 104 cap. That's pretty much it. Very simple.